So we're talking about sinusoidal transformations today. You're going to remember yesterday you were introduced to sinusoidal functions, and I just want to do a quick review. I want to remind you that the word sinusoidal refers to any sort of graph that has a wave to it. Sinusoid, I don't know what I did there. And the two graphs we've learned about are sine and cosine. And in yesterday's class, we learned that these graphs have a specific shape. So a sine graph has this shape, and a cosine graph has this shape. And the biggest difference is a sine graph starts at 0, and the cosine graph starts at the maximum value, which is a 1, and the minimum value is a -1. We also learned that the period of these graphs is 360 degrees when it's the parent function. But today with transformations, we're going to be like shifting it left and right, up and down, flipping it around, and all that sort of stuff. And then we also learned something called quarter period. So I'm going to review that and talk about it a little bit more. Does anyone have any questions about this before we start transformations? All right, so take a look at the top of this page. I have given you the general formula of all the sinusoidal function transformations. Let's just break this down a little bit. First of all, I want you to notice that you can have an x, but often it's written as theta, and that's just because whenever you're dealing with angles, your x-axis is going to have angles in it, right? So that's why we represent theta, but really theta in this case is just your x value. So here we have the word sine, here we have the word cosine. If you have a letter A in the front of the function, what that means is, remember in a regular graph, the letter A was a vertical stretch or a vertical compression. Well, in our situation, it's going to represent the amplitude. So it's going to tell you how high from the middle of the graph you're going up and how high or how low you're going. And that makes sense, right? Because the amplitude is like your stretch or your compression, your stretch and your compression. So the A value is going to tell us what our amplitude is. I'm going to move on over to the C. Usually the number at the end of the function represents a vertical translation up and down. So in this case, the letter C is going to actually tell you your equation of axis. And wherever you draw your equation of axis, that's how much the graph has shifted up or down. So that tells you if you're moving up 3 units or down 2 units, etc. Okay, then I'm just gonna go into the graph right here. The letter D represents your horizontal translation. Just like before, a negative number means you're actually moving to the right, a positive number means you're moving to the left. And the word that we give this is actually phase shift. So phase shift is just a fancy word for a horizontal translation. And then the part that is the newest in this whole lesson is this letter K, which usually represents our horizontal stretch or compression, is now going to be represented by the word period. So remember, the word period is the beginning of the graph to the end of the graph. How many units is it covering? So if you have a horizontal stretch or compression, it's going to affect where you start and where you stop. So that's why the period changes with that K value that changes. There is a formula that we need to memorize, and it is period is equal to 360 degrees divided by K. And we're going to be using that quite a bit. So just remember that when we do our calculations. Okay, you probably have questions about this, but we're going to get right into an example and see if it makes sense. You guys make sure you have a ruler because you're going to need to draw your axes with rulers. So I'll give you a second to take those out. Question number 1 says graph f of theta is equal to 3 cos theta plus 2. We're going to start off with a really easy example because you're going to notice that in this question, our theta is all by itself. We don't have a K value. We don't have a D value. So really, all this graph it has is the A value in the front and the C value at the end. Okay, so let's figure out what all of this means. We will begin by the 3. The 3 represents your amplitude. So that means we're just going to fill in the chart and write 3 for amplitude. The positive 2 tells you your equation of axis. So I'm going to go all the way to the bottom of the chart. I'm going to write y is equal to 2. That's where we're going to draw our equation of axis. That's actually enough information for us to begin the graph, right? Because I always start off with the equation of axis, which is 2. And then an amplitude of 3 means you're going to move up 3 from the 2 and then down 3 from the 2. So let's go ahead and actually start putting in our numbers for our graph. Okay, so we always start at the 0. we need to go at least up to a 5 and at least down to a -1. So 1, 2, 3, 4, 5. Then I'm just going to make my equation of axis with a dashed line. And I'm just going to label it somewhere with y is equal to 2. Okay, I'm also going to just recognize that the 5 is my maximum value and the -1 is my minimum value. So I do like to write that on the graph because it just makes it so much easier when you're graphing. Maximum and minimum. All right, so that's a pretty good start to our graph. Now we need to figure out what we're going to put on the x-axis. And in order to figure that out, we have to determine what the period is. Okay, so remember, our formula for period is period is equal to 360 degrees divided by k. What is the k value? The k value is whatever number is in front of the theta. So in this question here, what can we say is our k value? Yeah, so there's no number here, which means really our k is equal to 1. So when we do the calculation, we're just going to say period is equal to 360 degrees divided by 1, which means it's just 360 degrees. That means from the start of our graph to the end of our graph, we need to cover 360 degrees. Okay, last class I kept saying something important happens every quarter period. What that means is you take your period, you divide it by 4, and that is the number you know you're going to go up by on your x-axis because an important change or like shift or curve is going to happen at that time. So in order to figure out the quarter period, we're going to take our period, which is 360. We're going to divide it by 4, and we're going to get 90 degrees. Is there a phase shift in this graph? Do we have a number after the theta that tells you you're moving to the right or to the left? There isn't, so we're just going to put a dash or nothing there. And the template is just what I write down to tell me how many units I'm moving to the right or to the left. And that's often just your quarter period. If there's is 90 degrees, and that's what I'm going to be putting on my x-axis. Let's do maybe just one. We can just do one cycle just to keep it easy for ourselves. So I'm going to make a dash. 1, 2, 3, 4. Should we do 2 cycles or 1? Okay, maybe for this first example, we'll just do 1. So 90, 180, 270, and then 360. All right, now, how do I know what shape I need to draw for my graph? Word cosine or sine? I see the word cosine, and that tells me the shape is going to look like this. So it's basically going to start at the maximum. It's going to go to the equation of axis. It's going to go to the minimum, back to the equation of axis, and then all the way back to the maximum. Okay, so let's draw that out. Okay, so I'm going to start at the maximum and move over a quarter period every time you're drawing your next dot. Also, what is a 0? The 0 is always the equation of axis. So I started at the maximum, then I went to the equation of axis, then I'm going to go all the way to the minimum. I'll go back to the equation of axis, and I'll go up to the maximum. And that shows me one cycle of this graph. Now, technically, you can have an arrow. If you are making an arrow, make sure it's pointing down because this graph is a curve, right? So if the graph were to continue, it would continue in a curved line. It wouldn't go up. It would actually go back down. Just like before, we do need to label this. So we're going to label this with f of theta is equal to 3 cos theta plus 2. And then I do a quick check just to see if I have all the information. So I look at my information. Is my equation of axis at y is equal to 2? Yes, it is. Is my amplitude 3? Yeah, because from 2 it goes all the way to 5, and then from 2 it goes all the way to -1. And then is it a cosine graph? Yeah, it looks like a letter U. And from start to stop, do I cover 360 degrees? Yes, I do. So that means this graph is correct, and we're done. Now, I only drew one cycle. If I asked you to draw another cycle, you are allowed to have calculators. So you would just go 360 plus 90, and then plus 90 plus 90 plus 90. You would draw 4 more dashes, and then you would just continue the shape of the graph. Okay, graph number 2. Graph f of theta is equal to -2 sine theta plus 1. Now, I notice we have a -2. I'll tell you what to do with that in a second. Let's just start with the information that we are used to starting with. So let's begin by figuring out what our amplitude is. It's just going to be a 2. I don't put a negative. Remember, amplitude can never be negative, so it has to be positive. My equation of axis is just y is equal to 1. And then with that information, I actually start by putting in values on my y-axis. Okay, so I know the graph begins at 1, it goes up 2 units from there, and then it goes down 2 units from there. So I have to go all the way to 3 and all the way down to -1. Okay, so 1 is my equation of axis. I'm going to go ahead and draw a dashed line there. Is that kind of straight? That's good enough. Let's just pause. All right, so I'm going to just label this line y is equal to 1. And then I also just like to make a note of where my maximum and minimum is. So and by the way, if you're wondering why I'm not writing the other numbers, I'm just being lazy. I probably should do that. So I'm going to put in a 2 here, and then that's really it. If you wanted, you could go -2. Okay, so your maximum is from the equation of axis, you're going up 2 units, so it's going to be there. And then your minimum is from the equation of axis, you're going down 2 units, so it's going to be right around there. Okay, so I'm just going to label this max and label this min. Are you guys okay with that? Yes? Do you need a second to just write all that stuff? Okay, I'll give you a second to. Okay, so just like the previous question, what is the k value in this question? To find that, we're just going to go and look at our theta and see if there's a number in front of the theta. There doesn't seem to be, so that means technically your k value is just going to be the number 1. So right here, your k value is equal to 1. I still show all of my work when I'm writing it in the chart, just for like the more you practice doing that, the better you get at it. So for this one, our period is equal to 360 degrees divided by k, and our k value is a 1. So it's going to be 360 divided by 1, which is 360 degrees. To figure out our quarter period, you take your period and you divide it by 4. So it's going to be 360 degrees divided by 4, which is equal to 90 degrees. So the exact same as before. We do not have a phase shift. That means the graph is not moving to the right or to the left because there's no number that comes after the theta. And that means our template, which is just what we're going to be putting on our y-axis, is whatever the quarter period is in this case, and it's going to be 90 degrees. Maybe for this graph, we can do 2 cycles just for practice. So we're going to go 90, 180, 270, 360. That's our first cycle. Then we're going to add 450, 540, 630, and 720. And you definitely can have calculators. You know how yesterday I wasn't sure? I forgot how much of this stuff you have to do, so you can have calculators for sure. Okay, so we have 450, 540, 630, and then 720. All right, now you're probably wondering, what are we going to do with that negative? And I have to show you what we're going to do. Agree? If there's no phase shift. If there's a phase shift, then you have to do a little extra step. All right, so I'm just going to go to the side over here. Feel free to copy this down as well. Okay, so here is the graph for sine theta. We know this, we learned this yesterday. The graph for negative sine theta is just the flipped version of it. So f theta is equal to negative sine theta. So if there's a negative sign, it means you're going to be drawing the graph flipped over, and it's going to look like that. So in this example, we're going to still start at 0, but now instead of going to the maximum first, we're going to go to the minimum. Then we're going to go back to our equation of axis. We're going to go to the maximum, and then we're going to go back to the equation of axis. So just make a note to yourself that that's what a negative sine theta graph looks like. And does this make sense? Well, a negative on the outside means it's a vertical reflection. And yeah, the graph is like flipped over vertically along the x-axis, so that reflection does make sense. All right, so I'm going to come over here and I'm going to start at my 0. Remember, your 0 is wherever your equation of axis is. It's not your x-axis, it's the equation of axis. From there, you move over a quarter period, you go to your minimum, move over a quarter period, go to the equation of axis, move over a quarter period, go to your max, move over and go back to your equation of axis. And that's actually the first cycle. And then from here, the pattern just repeats itself. So you're going to go move over a quarter period, go to the minimum, 0, maximum, 0. And if you wanted to continue with arrows, which you should, this graph actually just goes, keeps going down. And this part of the graph just keeps going up. We're going to label this f of theta is equal to negative 2 sine theta plus 1. By the way, how will you know how many cycles to draw? I will tell you on the test. So I'll say, draw this for 3 cycles, draw it for 1 cycle. And then you'll know how many times you need to repeat it. Let's do a check. So is the equation of axis at y is equal to 1? Yes, it is. Is my amplitude 2? So that means from the equation of axis, does it go up 2 and down 2? Yes, it does. From the start of the pattern to the end of the pattern, like 1 cycle, have I covered 360 degrees? Yes, I have. And something important is happening every 90 degrees. So we've covered everything. And by the way, the negative means the graph is flipped over, and that's correct as well. Okay, so I know this is going to bother the type A OCD people in the class, but we're going to be skipping question 3. We're actually going to do that in tomorrow's class because question number 3 is, I think, one of the more challenging ones. We're just going to finish off with questions 4 and 5 today. Okay, so question number 4 says graph f of theta is equal to negative 3 cos. Now we have something in front of the theta. It's a 2 minus 1. Let's begin where we always begin, which is with my a value, and that's a 3, because remember, your amplitude always has to be positive, so you're never going to write the negative. It'll just be a 3. What is the equation of axis in this question? Y is equal to negative 1. And so now I can go ahead and write in the numbers for my y-axis, because it means my graph starts at negative 1, it goes up 3, and then it goes down 3. So the highest I'll go is the number 2, and the lowest I'll go is the number negative 4. All right, so my equation of axis is negative 1. I'm going to just draw a dashed line there. Nope, that's not even hitting the negative. That's closer. Okay, I'll pause this so you can't watch experts at the end of it. All right, so y is equal to -1 is the equation of axis. And then from that position, I'm going to figure out that I move up 3 units to get all the way to the maximum, which is going to be the number 2. And then I go down 3 units to get to the minimum, which is going to be the number -4. Okay, get excited because we finally have a letter K. In this question, actually, do you need a second to finish that off? In this question, the number in front of the theta represents your K value. So K is equal to 2 here. And that means when we're figuring out the period, remember the equation for period is 360 degrees divided by K. So the calculation we're going to have to do is 360 degrees divided by 2, which is going to give me 180 degrees. What does this mean? This means that one cycle from start to finish has to be 180 degrees. No, because what that means is if a regular graph is 360, if it's compressed, now it's from 0 to 180. So that takes into account the horizontal compression. Exactly, yeah. So the fact that now your period is smaller, it means you're squishing your entire cycle into a smaller space. Pretty cool, right? You don't have to actually think. All right, so yeah. You don't have to flip the K value. No, no flipping. All right, now to figure out our quarter period, we're gonna go 180 divided by 4, which is gonna give us 45 degrees. There's no phase shift again in this question. A question without a phase shift is much easier. The phase shift adds like an extra level of complexity. That means our template is just gonna be whatever the quarter period was, it's gonna be 45 degrees. So here's what I really do if I don't want to think. I take my calculator, I go 45 plus 45, and I just keep pressing the equal sign to get all my numbers. That's like a pro tip if you're really lazy, if you don't want to think. So let's go ahead and do 2 cycles of this. We're going to start with 45. Then we're going to get 90. Then we're going to get 135. And then we're going to get 180. So from 0 to 180, that's going to be our first cycle. And then the next number is 225, then 270, 315, and 360. All right, there's one thing we haven't taken into account, and that's the negative sign. So let me tell you what a negative cosine graph looks like. I'll just go to the side again. As a reminder, a regular cosine graph looks like this. So that means a negative cosine graph is just going to be flipped over and it's going to look like this. So this tells us our pattern. We're going to start at the equation of axis, go to the maximum, equation of axis, back to the minimum. That's sort of the shape we're going to follow. Okay, so I go back to my graph and I have the minimum, move over a quarter period and go to your equation of axis, move over a quarter period, go to your max, then equation of axis, and then back to the minimum. Oh my gosh, my hands are sweaty, so I cannot draw this curve. That's good. So this is one cycle of it. From start to stop, you've gone from 0 to 180. Let's just continue the pattern. So now we started the equation of axis. We go to the maximum, equation of axis, and then back to the minimum to draw our second curve. If you wanted to continue this line, make sure you draw your arrows appropriately. So it's going to be pointing upwards, right? Because the graph isn't going to continue down, it's just going to keep going up. Oh, it's a little messy. I'm going to fix that up later. We need to label our graph. F of theta is equal to -3 cos 2 theta minus 1. Okay, so let's just think about this for a second. The number 2 inside represents a horizontal compression. That means you're taking your graph, which is usually from 0 to 360, you're compressing it, and that's why now the cycle is from 0 to 180. It's a shorter cycle because you've squished the graph. Our equation of axis is at -1. Our amplitude is 3 up, 3 down. From start to stop, it's 180, and it's a negative cosine graph, so we've done everything. That is our final answer. All right, you guys, last example for today, question number 5. In this example, we actually have a little bit of everything for the first time. So if you take a look, we have a negative in the front, we have an amplitude, and then we have a number in front of the theta, we have a number with the theta. And we have a -2. Let's sure the phase shift is going to be to the left. So maybe just copy my X and Y axes just so that you don't run out of space when you're doing it later. Okay, but the rest of the process stays the same. So I'm going to begin at -2. I'm going down 3 to -5 and up 3 to +1. So here's what it's going to look like. It's going to be 1 and then 1, 2, 3, 4, 5. Okay, my equation of axis is -2. And this time I'm actually going to extend that line all the way through that way. It's crooked, I can't look at it. I need to move past it. Okay, y is equal to -2 is my equation of axis. And then from there, I can identify that you're going to move up 3, 1, 2, 3. Your maximum value is just going to be a 1. And then from there, I'm going to move down 3, 1, 2, 3, and my minimum value is going to be -5. Okay, super exciting. We have our k value, which is the number 3. So k is equal to 3, and so we need to show the math for this in our chart. The equation for period is 360 degrees divided by k. So we're going to go 360 degrees. Sorry, and k is the number 3. So I'm actually going to write that in. So 360 degrees divided by 3, and that's going to be 120 degrees. That means from the start of our pattern to the end, it'll be 120. It just means there's a really big horizontal compression, like our graph is really squished horizontally. Our quarter period is going to be 120 divided by 4, and that means it's going to be 30 degrees. Every 30 degrees, an important switch is happening in the graph. We actually have a phase shift now, and this phase shift is 60 degrees to which direction, the right or the left? Good, it's going to be 60 degrees to the left. So you're probably super curious and want to know, what are we going to put on our x-axis? Are we going to put the quarter period? Are we going to put the phase shift? What we're going to do is we're actually going to take the greatest common factor of these two numbers to figure out what our axes number should be. And from my experience, this is the most efficient way to do this. You could use logic to kind of figure it out, and that's fine. Like, you don't have to use this method, but using this method does work. So I look at 30 and 60, and I recognize the common factor between both of them is just 30 degrees. And that means we're going to be going, our template is going to be 30 degrees. Now, because we're moving 30 degrees to the left, we do have to get into negative numbers. So from 0, this is going to be -30, and this is going to be -60. And then let's do a couple of cycles. So it's going to be 30, and then 60, 90, 120, 150, 180. I don't know if I'm going to need all these numbers. I'm just going to keep going. 210, and then 240. Okay, so I've written down my X values and I've gone up by 30 degrees. I do a little bit of an extra step in this, actually, no, I don't have to do an extra step. It is a negative sine theta graph. What does that mean? The shape of this graph is going to look like this. So I'm going to begin at my 0, which is not going to be a 0 because there's a phase shift. Then I'm going to go to my minimum. Then I'm going to go back to the equation of axis, the maximum, and then back to the equation of axis. Okay, here's the trickiest part, you guys. Where exactly are we going to start? I know we have to start at the equation of axis, so that's my position here. But I also know there's a 60-degree left phase shift. So my starting point is actually going to be at negative 60 degrees, comma, negative 2. Then I'm going to move over 30 degrees because that's my quarter period. And I'm going to go down all the way to my minimum. And I'm going to draw a dot at negative 30 degrees, comma, negative 5. Why did I do that? Well, the quarter period is 30 degrees. That tells me how much I have to move across every point. And this shape tells me that I go down to the minimum, and that's why I went to the minimum. And then from there, it's pretty straightforward. You're just following the pattern. So you go back to the equation of axis, move over 30 degrees, go all the way to your maximum and move over 30 degrees, and then go to the equation of axis and move over 30 degrees. So here's what the shape of the graph looks like. And we have to just pause here and see if this makes sense. Is the equation of axis at negative 2? Yes. Is our amplitude 3? Yeah, because from negative 2, you're going up 3 and down 3. Have we covered a period of 120 degrees in total? Not worrying about negatives and positives. We started at a 6 here and we ended at 60 degrees here. So that means from the start of the graph to the end, we have covered 120 degrees. So we're doing it correctly. And quarter period means something important is happening every 30 degrees, and we've phase shifted 60 degrees to the left. So we're on a really good track. Let's do one more cycle of this. So we're going to go from this, we're going to go 90, comma, negative 5, then back to 120, comma, negative 2, then to the maximum, and then back to our 0, and we're going to stop right there. You could draw an arrow just to show the graph continues this way and this way. Oh no, why did I do that? There we go. You label your graph. F of theta is equal to negative 3 sine bracket 3 theta plus 60 degrees. Need to move over, minus 2. And that's our graph. Okay, I'm going to pause here and we'll continue the other